So, vectors. A vector has magnitude and direction. Vector is a quantity that has both size or magnitude and direction. And examples of vector quantities are displacement, velocity, and force. A vector can be represented using a line segment with an arrow on it. For example, the magnitude of a vector is given by the length of the line. The direction of the vector is given by the arrow on the line. So this representation here shows us a line, AB. That is the vector, the magnitude of that vector, and the arrow here in the middle of that line is indicating the direction. Again, the vector goes from point A to the point B. We can write this vector as AB. The arrow above that line indicates the direction from A to B. Vectors can also be written with single letters, bold letters. The majority of the time in text you will see a bold letter above that vector which indicates it. When it is handwritten, it is a lowercase letter and there will be a line below it, but that's when it's handwritten. In most texts you will see a bold letter, so it may be an A, B, C, D, whatever the publisher may want to denote it with. To go from the point A to B, we must move 6 units to the right and 3 units up. So we're moving from A to B, and as you can see it's indicated here. I'll count the spaces for you. 1, 2, 3, 4, 5, 6. 1, 2, 3. We can represent this movement using a column vector. And this is what indicates a column vector. The first number, this is the horizontal component. It tells us the number of units in the x direction. And the bottom number, this is the vertical component. It tells us the number of units in the y direction. Now that comes from our former, or what we've used before, the Cartesian coordinates. With respect to the graph, you have the y-axis and the x-axis. And this is something we've discussed in previous classes. Now, adding vectors. Adding two vectors is equivalent to applying one vector followed by the other. For example, suppose we had one vector A, which had the coordinates 5, 3, and B, which had the coordinates 3, -2. If we were asked to find A plus B, this is how we would represent it. So we can see, with A, we were told that the vector had coordinates 5, 3. I'll give you an indication. A is here. We have 1, 2, 3, 4, 5. 1, 2, 3. That is our A, as indicated here. Our B has 3 with a -2. So we start here. This is our tail. 1, 2, 3, and we come down 1, 2. That's why we have the indication of a -2, because we are going in a negative direction. When two or more vectors are added together, the result is called the resultant vector. And this AB, which has been attached to it, from the tail of A to the head of B, is the resultant vector, AB. And in this case, we stated 5 was the x number for the A vector, and 3 was the x for the B vector. 5 plus 3 gave us 8, and the y values, 3, minus 2 gave us 1. So, in general, we can add two column vectors by adding the horizontal components together and adding the vertical components together. Now, addition of these vectors. So, vectors A and B are represented by the line segments, and they can be added using the parallelogram rule or the nose to tail method. Again, this is the tail, this would be the nose, this would be the tail, this would be the nose. Sometimes you would hear the expression head and tail. The tail of a vector B is joined to the nose of vector A. So this is my vector A. As I said, tail is at X. The nose will be here. Vector B has been joined to A at its nose and goes to Y. The resultant vector is A plus B. And again, it states, alternatively, the tail of A can be joined to the nose of vector B. So this is just a different orientation of the same thing occurring. In both cases, the vector xy has the same length and direction, and therefore A plus B is equal to B plus A. So we have AB here and B plus A here, which are both the resultant vectors. Now, we've just gone through addition. We can also subtract vectors. We can subtract two column vectors by subtracting the horizontal components and subtracting, again, the vertical components. So for example, suppose we had A with the coordinates 4, 4, and B with the coordinates -2 and 3. And we were asked to find A minus B. So we would set our problem out as such, A minus B, and then we would have our coordinates set up. Now, 4, 4 minus a -2, 3 is equal to 4 take away -2 and 4 take away 3. Now, the law of multiplication will come into play here because a minus times a minus is going to give us a plus. Therefore, our resultant column vector is 6, 4 plus 2. A minus times a minus gives us a plus, which gives us 6. And 4 take away 3 gives us 1. To show the subtraction in a diagram, we can think of A minus B as A plus minus B in bracket. So again, we have two vectors here. One B is positive, one is negative. So we stated our A, which was 4, 4, and our B, which was -2, 3. So, again, A minus B gave us 6, 1, which was indicated earlier. Now, I want to stop there because these are some of the things that we are going to be going into. And I want to do some problems with you with respect to adding and subtracting. We will be moving on to multiplication maybe in our next lesson, but I want to make sure that we will go through this of adding and subtracting. So I have some problems that I'm going to have you do. And if you open up your books, we'll get to this.